Good morning, all. Welcome to DELSA Day 2. I think we all enjoyed yesterday's discussion of the quantified human, learning a little bit more about Larry and hearing his stories, and then also hearing about Mike Snyder's data and so forth. I think we actually had a good session. Today we're going to talk to or hear presentations from several of our esteemed colleagues talking about not only the work they do, but also the kind of work that DELSA might focus on in upcoming time here. So without further delay, why don't we start with Geoffrey.
All right, thank you. So I'm going to talk about training data scientists. And I start with the standard slide pointing out that McKinsey said there were 1.5 million managers and up to a couple of 100,000 technical people needed in this area by 2018 in the US. And presumably is some factor of 3 or something larger worldwide. There's lots of people discuss education in data science. And it's just sort of it's an interesting area, and the fact there are so many jobs suggests to me that some sort of data science will become a curriculum topic of great interest in many universities. There's nothing like students wanting to get jobs in the area, and it varies from areas such as policy and curation, applications, algorithms, programming models, lots of data mining and statistics, and plenty of CS topics. And you can obviously offer this as certificates, minors, tracks, real degrees, and what have you. And you can implement it, again, as departments, programs, ... So that's happening. This will presumably happen and is happening. I'm going to discuss a particular take on that, namely MOOCs, and I think MOOCs are particularly relevant for data science, as this is you couldn't view MOOCs as a way of teaching your introductory courses because they're so common, but you can also view it as a way of jump-starting new fields where there isn't curricular material broadly available, so it is of some interest to try to do that. So I wanted to discuss the experience I've had at Indiana University, which is using Google Course Builder, which is notable for its total simplicity, but this may not be a bad idea. And the essential idea of Google Course Builder is that we use the iTunes model, or whatever, or Winamp model, namely, you think of your course as a collection of what I call lesson objects, which are 10 to 15-minute segments. Those segments are typically, but don't have to be, what I would call video over PowerPoint. And what Course Builder does, Course Builder is an open source Python code, it builds playlists, which again are familiar from the music field. And so your course, your lecture becomes a playlist of, and then on top of that, and your whole course becomes a playlist. So my suggestion is that if DELSA could consider building such objects, and those just go into a repository like iTunes. And here are some just simple examples. This is my course, Codex Informatics, which is basically data science. And you can see here we have 5 lectures there. Each lecture, here's one lecture, has seven songs in it, 7 10-minute segments. And Course Builder takes care of all the rather trivial bureaucracy here. And the video is stored on YouTube, and the actual, the rest of it is stored on Google Docs. And I note that one key feature of MOOCs is you do not have to teach 100,000 students. Because this is a repository, you can think of this repository as something which is customizable in different ways. So you can teach 1,000 courses, each to 100 people, because you have your repository, you can customize it in different ways, because different students will have different demands. And so one of my colleagues is using that to customize a cloud computing MOOC to deliver to historically black colleges and universities where the preparation of the students is not as good, and therefore the same course that is taught at IU is not suitable. But in my opinion, that particular customizable model is maybe a better model because it also doesn't run into any trouble with mentoring, because you can use the same mentoring model as normal, because you're not having a huge number of people at any one time. And that's Google Course Builder allows you to build many different user interfaces. Here's a cloud computing MOOC with a different user interface. And these songs or lessons objects you can prepare in many ways. I just prepare it using Adobe Presenter on my laptop. And that's it. Thank you.
Let's get that fixed. I wear a lot of hats. And one of them, I'm a co-PI on an advanced technology education grant for the National Science Foundation called BioLink. And BioLink is a national center that serves, about 93 college programs at the community and technical colleges, and then some universities as well across the United States. The programs offer 2-year degrees, associate degrees, some transfer degrees, and several certificates. Many of our students, actually about half of our students, often have bachelor's degrees, and they come to the community colleges because in their university training or their 4-year college training, they did not get the skills that they needed to get a job. And so they come to the colleges to learn the hands-on skills that they need to go out and enter the workforce. And then a lot of them, there's a lot that come also because they've been working in other careers and they want to change, or perhaps they were working in the workforce and they want to upgrade their skills, or they want to get into a new area. They've been doing cell culture and now they want to try DNA sequencing or something like that. So they'll come to the community colleges to get a certificate and go out and work. So I'm here. I should say also that we've been doing this for 15 years, helping these colleges establish programs. BioLink started as a way to help colleges start programs and to help them develop their connections with industry. So almost every single program has an industry advisory board, and many of the faculty in the community college programs either teach part-time for the colleges and also work in industry, or they do internships in industry so that we get a pretty good feel for what people do. So I'm here largely because I actually know what our technicians are doing out in the field, but I don't know what they're going to be doing necessarily with data-enabled life sciences. So what do they do now? All right. This is a picture I took from, this is one of our graduates who is working in an incubator in Texas. And what she's doing, notice, I was really impressed to see all the labs, all the biotech labs are using iPads. That was a real surprise to me, that they've become very, very common out there in the life science industry. So what's she doing? Okay, she finds information in databases. She designs PCR primers. She is using informatics to design plasmids, to clone things. She's tracking data, storing it in electronic notebooks so that other people can access it and it can be shared. She uses a lot of web forms, are very, very common. The students or graduates use a lot of Excel, so lots of spreadsheets, graphing data, interpreting data. They have to be able to be very visually literate, so they see graphs and they have to figure out what's going on. So I think a lot of this is relevant when we're thinking about how are we going to train future technicians in data science, because we have to realize that they don't spend 8 hours a day with a computer, all right? They spend a lot, they do work with computers, but notice she's at the lab bench. So she goes and she does her, sets up her experiments, and then she comes back and works with the computer for a little bit. And what that means is that we can't expect them to learn how to program. We can't expect them to learn really complicated interfaces. They have to be able to learn things quick. And the life cycle for the software that they're using has to be a bit slower. We can't have interfaces changing every year, all right? Because they don't have the time to devote to learning new things over and over again. They have to be able to do it quick. It has to work. It has to be like iTunes. It has to be reliable. And 40 seconds.
Absolutely. You are way ahead of schedule.
Good morning. Thank you for having me here. I was actually in Iraq, I guess, yesterday morning, and so I apologize for not being here yesterday. I chose this photo to show you, first off, because I would imagine that this is not the picture of Iraq that you think of when you hear the word Iraq, based on what you see and hear in the news. But I think that this photo of some of our students at the American University of Iraq Suleimani demonstrates a few of the phrases from the DELSA mission and vision. And one of them is global society. The other, transdisciplinary engagement and collective innovation. So I want to briefly talk about the current paradigm of education in the public Iraqi system, and then talk to you about how AUIS is trying to change that and how I think it's relevant to life science in general, and especially data-enabled life science. So the Iraq public education mandates early specialization. So imagine if you took the SAT in 6th grade and your score entirely determined your career trajectory, and there was no way you can change it because the government wouldn't let you. Students take a baccalaureate exam in middle school, and depending on how they score, they are placed in either the science track or the literary track. And it is very difficult, if not impossible, to change tracks after that. Based on their baccalaureate score, their high school education is tailored and specialized, and in fact, this does work very well for a lot of students. I'm not saying that this is always bad, but for many other students, by the time they get to their higher education, they have been specialized for so long that they haven't, for example, taken a biology class, maybe since the 6th grade. And what then they take in high school is another baccalaureate exam. And that not only determines where they can go to college, but it determines what they can major in. So the top few percent can go on to major in medicine, pharmacy, dentistry, and then after that comes engineering, and then some of the other sciences come lower than that on their baccalaureate scale. And then the literary track has another ranking system. And so they are not allowed to major in the sciences unless they are on the science track and can score that certain score on one exam. There are other factors, but by and large, it's the baccalaureate score. So what AUIS is trying to do is to bring a different model, but different paradigm of teaching that probably is familiar to most of you sitting here, and that's the American style of education where we do emphasize, at least to some extent, transdisciplinary engagement in education. So what we have is a 48-hour core program, and this is where I've been teaching exclusively for the last 2 semesters. I teach the life science course, and I've taught some core options, one in genetics this semester. But all of our students, no matter what track they've been on in high school, take English, civilization, life science, physical science, math, stats, and computer science in their first 2 years. Then they go on to their majors. So what we've been trying to do is use that 48 credit hour core program to teach them how to think. Most of their educational experiences for most of my students has been based on rote memorization and regurgitation of information. And in fact, I've had several students say to me over the course of the last 2 semesters, "Professor, we don't like to think." And I try to tell them that you can think. It's not that you can't think. It's that I'm trying to teach you how to think and that you can think. And what I've noticed is that when I'm in class and I'm lecturing at them, like many American students, no, they probably don't like to think. They just want to know, is this going to be on the exam? Right? Do I have to memorize this definition word for word? Is it going to be on the exam? But when you give them a challenge, especially a question that's relevant to their lives and relevant to one of the pressing complex issues in the Middle East, their attitude changes almost immediately. So on the upper right, this photo, I guess I can't use it, the upper right shows some of our students in the Microsoft Imagine Cup. And the challenge for the Microsoft Imagine Cup, it's simply imagine a world where technology helps solve the toughest problems. And our students, our IT students, took the top 3 spots in the regional competition in 2012 and went on to the national competition. We've had students win regional competitions for the Holt Global Case Challenge, and we also have had students doing amazing things outside of the sciences. So the photo on the bottom left was a play that I saw a couple weeks ago as part of a festival called The Art of Social Justice. So how do we use art to address social justice problems in Iraq? And this was a play called The Arranged, on the very sensitive subject of arranged marriages in Iraq, in particular Iraqi Kurdistan. And this was entirely written, directed, and acted out by our students, and it was phenomenal. So what I think, and what I hope that we can do, is to bring a different paradigm of creative, collective innovation, not just to American students, but to students all around the world who are not used to this, but when you give them a pressing challenge and a question that's relevant to their lives, can engage with collective and innovative research, and they are going to be the ones who have to solve these problems in their own countries, and the problems they have are complex and they cannot be looked up in a textbook. So any ideas that you guys have about how we might bring educational modules that I could use in my life science class, I am all ears. Thank you very much.
Internet 2 is currently working on 3 big data challenges. The first is basically just moving the data, and a good example of that would be a demo that we did last June with BGI, UC Davis, and NCBI. And at that time, we moved a 24 gigabyte file from Beijing to UC Davis in 30 seconds. So it is possible to move really big data very quickly. But it's not necessarily easy. You really do have to have a big pipe all the way from one end to the other end. And typically, these network pathways have a bunch of bottlenecks. So you need some mechanism to find the bottleneck and fix it. I say bottleneck, actually bottlenecks, because there's never just one. You also need software on both ends of this kind of connection capable of getting the big data onto the pipe. Now, there are a number of different packages out there that can do that. In this case, we used Aspera. Globus Online is another good candidate for this. BitTorrent is another. So it can be done, but it's not trivial. This is a case where Internet 2 likes to help its members make this happen. A second problem that we're looking at and working on is security. And so if you look at a place like MD Anderson, they've decided that they're going to sequence, actually whole genome sequence, all of their cancer patients. So we're looking at a lot of data. I mean, they are the largest cancer center in the country. So not only is it big data, it's sensitive data. It has to be protected. So how do you do that? Somehow you have to take the traditional CIA triad found in security, the confidentiality, integrity, availability, and combine with that performance. It's actually harder than you might think. So that's a problem that we're working on with our friends at ESNet and also many of our members who have received NSF CCNIE funding. A third problem that we're working on is the storage and compute, which of course I'm sure many of you face. Many people feel like cloud computing will be a major answer, in part because it solves part of the moving data problem. Once you get the data into the cloud, you don't have to keep moving it around. Many of our members are engaged in a variety of different projects involving clouds, public, private, community, hybrid, and typically our role with them is to make sure that the different locations are well connected. Today that means 100 gigabit pipe. Obviously there are still problems with clouds, especially the public clouds, But I think in the not too distant future, you're going to see more and more solutions that include BAAs and service level agreements. Finally, I want to mention an interesting program that's going on now that's called the National Center for Genome Analysis Support, NCGAS. There are 4 supercomputer centers that are involved in this, ones at IU, TAC, SDSC, and Pittsburgh. This is being led by Bill Barnett at Indiana University. And interestingly enough, the research infrastructure at IU actually is all in a HIPAA-compliant environment. This is something that I think you're going to see spreading. Other centers are going to want to provide this resource as well. I think that's it for me.
Good morning. So we moved from big data to little data, which is what I'll be talking about mostly. Gene asked me to talk. By the way, I'm the Chief Information Officer for Seattle Children's. Gene and I work together. I control the IS operations for both research, the hospital, and our foundation. And over the last couple of years, I'm going to try something that they tell you not to do during a presentation, which is a live demo. We've developed a private cloud that I'm a little bit proud of. 3 different Computer World Awards from this. But we really built it mostly, oops, you can't touch, this is not a touch screen up here, by the way, if you come up here and do a presentation. But we mostly built it for 2 reasons. One, what the previous speaker was talking about is that combined with our research data, we have a bunch of clinical data, mostly clinical data actually at this point in time. So I had to protect the clinical data while the researchers needed access to research data. And our way around that was to use a private cloud. Our cloud is built right now on Citrix. Our virtual, everybody who wants access to corporate resources at Seattle Children's gets those corporate resources through a virtual desktop. If they want to bring in a device through, which most researchers do like to have their own MacBook or something like that, we let them bring anything they want into the research facility, which may seem strange to you, but remember, we're attached to a hospital, so we have all the HIPAA constraints that everybody else has. So we need to give them somehow access to both the corporate data and the research data that they usually have on their MacBook. So what they do is when they come into our facility, we have a separate network set up for them, a wireless network set up for them, and they use that wireless network to get to, thank goodness, a virtual desktop. This is a virtual desktop that's running from our data center at Seattle, at Sandpoint Way in Seattle. And the very cool thing about this, just last week, I've replicated this data set, this cloud in another data center that's on the opposite side of the mountains from us on the Cascades. So essentially, if Gene had any trust in me whatsoever, when he went to a presentation, or if he had big data that he needed to move around, he could do the same thing that I've done here, which is use his virtual desktop from Seattle and get to any of his presentations. And it's actually pretty quick, too, if you didn't notice. I got to that whole thing initial logon is 43 seconds, and then throughout the day, as you move from one device to another, a clinician will move from one bed to another bed to another bed to another bed. That disconnect and reconnect is about, is about 6 seconds right now. So during one session, one shift, we measured one nurse move 48 different times during a shift. Couldn't do that legally with all HIPAA protection without our private cloud. So that's what I had to talk about, and I'm so glad this worked. It's embarrassing if the CIO doesn't work for me. Okay, that's it.
Actually, EMC owns VMware, by the way, so I can actually do what Wes did on my phone. But I can't demo it, so.
I can too.
Anyway, so I don't have any slides, so I'll just shut this down. Oh, well, you can turn that off if you want. But, let's have some daffodils. Or tulips. Okay. All right, tiptoeing through the tulips. All right, so I'll try and briefly introduce who we are. I did mention we own a small company called VMware as well, and RSA, by the way, and a new company called Pivotal, which spun off from VMware and Isilon, where I belong, and EMC, corporate. So Pivotal is actually a big data company. It's either going to do really well or it's going to fall on its nose. I think that, well, I actually had $150 million from GE as well, who's looking at the Internet of Things. How do you, actually, a jumbo jet flying across the Atlantic does about 50 terabytes of data. So this is not just life sciences, but a lot of other things as well. I'll talk briefly about life sciences. Isilon, whom I belong to currently, was founded in 2001. And Isilon is a storage company, a very interesting distributed storage company. Can actually do Hadoop today. We have a customer whom I can't name that just got 40 petabytes of Isilon storage for Hadoop number crunching, I guess. Some interesting stats, Google does about 2.5 exabytes a day, but 95% of that is useless stuff, like Justin Bieber tweets and what is that, Harlem Shake nowadays, or the cat and the baby in the cup or whatever. But in life sciences, you cannot throw anything away. I think all the CMIOs that I talk to, I guess Wes will agree with me, nothing is thrown away in life sciences. There's a gestation about 50 years, 75 some people say, but I think the FDA says 10. Just some stats about Isilon. We actually have an installed base of about close to 100 petabytes today with about 250 customers. All of the ENCODE project was done on Isilon, for example. Actually, the movie Avatar was done on Isilon as well. That's the two largest of our markets, is media entertainment and life sciences. Media entertainment is number one, but it's going down a little bit. Life sciences is going up. EMC purchased Isilon in 2009 for a very large amount of money, $2.5 billion, because the hope that as we scale in these massive data sets, somebody has to make this work in a production sense. John Halamka used to say, this is a funny joke, by the way, that the cloud is your mess run by somebody else. Mm-hmm. So I think you need to understand what your mess is. I also wanted to say that EMC actually teaches a data science class because we dog food our own stuff. I also wanted to say that, especially Delsa, I've known Gene for a little while now, and Todd as well. And I think it's marketing. And if you look at guys like Roswell Park, famous cancer surgeon, Sidney Farber, Mary Lasker, Everett Graham, it's all about marketing. And my other joke is the technology trickle down is first is defense, then there's a close tie between life sciences and pornography, and marketing is after that, by the way. insurance, and then commerce. And I think this is pretty serious. You have to market what you do. I think we as science guys and engineering guys are very, really insular in how we talk to people. And I say the story about Mary Lasker because she's the one who influenced cancer research in the early days, the 40s and 50s. And this is why the NCI was born before the NIH. I'm sure people who know this know this. And I always say that inside every big data problem, there's a billion little data problems. And people talked about N01 yesterday, and a couple of notes of people who've done this for 15 years, Google, Amazon, EMC. It is availability of data. So you have to have data very quickly. The operational expense, the cost of data for every byte. That is pretty important. And scratch space, when you do computing, what is the price of scratch? And flash memory is great nowadays, but it's pretty expensive. CPU acceleration, and finally density. So the top thing is availability. So everybody I talk to says data has to be available. If you're a radiologist, it needs to be there in 6 or 7 seconds. And I'll close with that. Thank you very much.
We were seriously looking at buying some Isolod stuff, really.
I was going to say,
I want to put a robe on.
yeah, I was going to say, we've got quite the contrast next door, so. The other NRA. Yeah, it's the other. Yeah. All right, we'll be nice. All right, well, thanks to each one of the presenters this morning. Again, you've now had a great cross-section of what it's like to train data scientists, what it's like to train life scientists, update from Iraq, which I thought was fascinating, Internet 2, private clouds, and now big data storage. I'd like to open it up to questions right now from the audience, or I know Sandy actually had an initial question for Geoffrey, but anybody would like to jump in?
Can I ask mine first?
Sandy, jump in.
Okay, since I'm here and I have the microphone, I'll start. One of the challenges I see, Geoffrey, is with MOOCs, or at least courses like that, because I've built my own course on a Drupal platform, and the challenge I have is with a large number of students, I would like them to be able to, I have to cut down the grading to keep the course manageable, and I've made my own queries to, whoa.
That's our answer to the prayers.
It's not me. I've written my own queries to set up pages to do that, but I was wondering how you do that with Google Player.
I mean, Google Course Builder. Google Course Builder does not discuss mentoring.
You can't do peer grading?
It's not, you can set quizzes and things like that, but it doesn't have any special technology for mentoring. As I said, my personal interest is not actually teaching 100,000 students at the same time, but rather setting up a repository which I can actually use in more conventional fashion with traditional sized classes. But all of these will obviously be explored.
How many Catholics in the room?
Yeah. So, Viral, would you like to ask a question?
Well, I don't know how to chant,
Well,
but
I do
I'll
several things in
maybe
group.
ask a
that's
question. Thanks, Rob, for chairing this, and also to all panel members. This was really a particularly good panel. Also want to comment on CJ's presentation. CJ, I think you're doing terrific work. You can't say this for yourself, but allow me to say that for you. This is really fascinating. It brings us insights from Iraq. It, I guess, forces us to rethink what we thought we knew. There is a lot of development in data-intensive sciences and big data all around the world. So this is very exciting, really. And I'm interested about the thoughts of this panel about, how to globalize this effort from your perspective, looking at from Iraq, whether MOOC type courses may play a role, or can you think things that we cannot imagine? And that's a general question, actually, for the whole panel. How do we make DELSA global, truly global?
So So who'd like to jump in? CJ, do you want to start? Because you're on the front line.
Sure. I've thought a lot about that in the past 2 semesters. And a few things I can share is being in a place that doesn't have a reliable supply chain for, say, laboratory equipment. And we have pretty good internet compared to the rest of that region, but the internet is still not reliable enough for me to do anything like a MOOC that requires us to be online consistently with a consistent speed for any more than a few minutes. So but what my students lack, and this is tested almost every day when I'm teaching it, is that they violate some assumption that I have of what experience I think they've had before. A lot of them don't have hands-on experience in the laboratory, in the field. So the photo I showed was of a botany course that was being taught by a visiting professor from Old Dominion University. And some of my students go on picnics every Friday. It's picnic day during the good weather. But the students said this is the first time some of them had been out in nature and actually looked at the plants and animals around them and thought about it. So even though some of them do get outside, some of them do have some experiences for hands-on learning, a lot of them do not. So what I think would work is maybe MOOCs, if they could be delivered in a way that takes into account the unreliable internet, but just having people work with my students in small groups, clusters, one-on-one, to show them how to do hands-on problem solving. And just one example, I'll give a brief example of that. Last year, we're still trying to develop our curriculum, so our curriculum is changing and hopefully getting more sophisticated. We've only existed since 2007, so a lot of what we do is new. But one of our science laboratory instructors last year took the physical science laboratory course, and instead of doing set labs that would have required a lot of equipment we didn't have, she made the entire lab about building a mousetrap car, and she made it a competition. And then at the end of the semester, we had the students actually try the mousetrap cars, and whoever car went the farthest won, and the students loved it. So things like that, where we give them the opportunity for hands-on learning, either in a computer, or in a simulated lab, or in a tactile sense, is what they really need. And we can't, I think when we go around the world and look at different science education systems, we can't assume that just because we in the US did something as middle schoolers or high schoolers or even as undergraduates, that doesn't necessarily mean that other students in other countries had that same experience.
I was going to ask a follow-on question to that. What is the cultural reception to bringing in these new ideas, especially for parents that haven't been through this kind of training before?
It's been tough at first. This is very, very new. But I think now that we've had one graduating class, this next week I'll go to the second graduation, and so we've had a few students graduate and go on, and they're actually starting to write articles. There's a great blog on our webpage written by a student who went on to grad school, and basically the blog said, I get it now. I get it why I was being forced to take religion classes and fine arts classes and politics classes and science classes with everybody, because it taught me how to think. So things are moving slowly. I'm, as a sister of an engineer and a sister of a nurse, I can totally understand my parents have a lot easier time explaining what my brother and sister do than what I do. So even here, it's difficult explaining to parents that you do something beyond engineer, dentist, pharmacist.
Yeah.
It's challenging, but it's moving along. And as more success stories build up, I think, from our students, the easier it's going to get to continue this change in paradigm.
Great. Thanks, CJ. Questions from? Oh, I'm sorry. Oh, sorry. Yeah.
I'll make a comment about international programs because there are research and education networks around the world. We've got peering agreements, I think, with about 100. And so we routinely meet with and collaborate with peer organizations all across Africa, India, China, etc. And what I'm finding is that they basically face the same kinds of problems that we face. Frequently in the last mile, it's difficult to deliver the kind of connectivity you'd like to have. In Africa, obviously, there's a huge penetration of cell phones. So if, in fact, the last mile can be delivered over cellular technology, then that's one kind of solution. In these pairing agreements, I've been working recently on an agreement with NKN, which is the Research and Education Network in India. And very soon we're going to have a 10 gigabit connection from the US directly to Mumbai. Well, I shouldn't say directly, it goes by way of Amsterdam, but there is also at this time an initiative going on to increase the transoceanic links, which today are primarily 10 gig links, and those are being increased to 100 gig in the near future. So at that point, it will be possible to deliver content for educational programs, but also, for that matter, even big data across the oceans. We do some of that now with the synchronization program from NCBI, where they connect to EBI in England and the DNA data bank in Japan. So there are a lot of international programs that make use of that kind of connectivity.
That's excellent. Thanks, Michael.
Hi, I'm hiding here. I just want to add that before we look outside, we should look inside. 33% of rural America, or 5,700 hospitals, don't have that much connectivity. And if you go to Tennessee or Alabama, I think you'll know what I'm talking about. So I think we need to understand that it is not just in Africa and India, it's actually here. The other thing I want to say is most of the Iraqi, I'm reading a great book called The Line in the Sand, most of the Iraqi and the whole Middle Eastern area is artificial boundaries. I think education is probably the greatest breaker of boundaries. Thanks.
I agree with the other answers. I think the two most important things are looking at making tools that will work with the objects and tools that people have on hand. Definitely, things that work on cell phones are great. I spent many years fighting with the high school teachers at my children's school because they wouldn't use computers in their science classes because not all kids had computers. Okay? But they all had cell phones. And if they would have been allowed to use cell phones in their classes, another issue. If they would have been allowed to use cell phones in their classes, and they could have used some of the applications on the cell phones, they could have been doing some very sophisticated things with bioinformatics tools that already exist. So making things mobile. The other really key thing is making things relevant. There's been a genome browser for James Watson's genome for several years that Cold Spring Harbor developed. I cannot get anybody to look at it. They don't care about James Watson's genome. Okay, so it has to be, we have to find problems that are of interest to them and relevant to their communities, and that is what really spurs them to want to go learn about things.
Thanks, Sandra.
One more example, there's a guy called Sean Eakin. He runs a company called Collaborative Drug Discovery. He actually has both an I'm not a Mac fanboy, by the way. He runs both an iPad and an Android application where you can do molecular structure for rare diseases on a phone. And a lot of the parents of people with orphan diseases, there are more than 2,000 or 3,000 of that, actually more than that. But so there's already technologies available.
One last thing that I should have said earlier, that I talked about testing assumptions when I'm teaching life science. And one of the other assumptions is that I can only bring things to my students and teach them things. And what I've learned is that my students can come up with creative solutions to problems that I would never think of and that none of us would ever think of. So I think that also we need to look around the world and realize that some of the innovative ideas are going to come from everywhere. So we just need to give them the tools to be able to connect and articulate those ideas to the rest of the world, not that we have to import our ideas everywhere.
Excellent.
So I just want to comment on the cell phone thing because I use peer instruction with clickers in my class, and now I was given a new technology that requires students to use cell phones, whereas I used to just say, okay, cell phones off, put them in your... And so now actually we are seeing, I think, more and more that education in the class requires cell phones. But apart from that, I had actually a real comment. So we see actually, especially in the big data, life sciences space, a lot of new technologies coming in, especially in big data. We have a lot of open source projects becoming acquired by companies or, being community developed, really well-known activities like Hadoop. I think this requires a push, or this actually provides a push for companies to be involved in the education. Or any breed of education. We see it with MOOCs and things like that to come together between universities and companies, because the traditional education won't scale, but also the companies, having their workforce developing educational modules for their own thing won't work. So there needs to be something in the middle, and I think we see it from programs like EMC's, data science education and things like that. So what do you think DELSA's role is then, bringing industry and academic and other partners together, also in the domain, to create these things and maybe to somehow spearhead some of these?
Yep.
I'm the EMC guy here. So yeah, we start, actually EMC is a very large academic collaboration network, close to 1,000 universities. Actually Pittsburgh is one of them, among many others. I think it's, well, I honestly believe that data science is a great marketing word. We still need to define that, what it actually means. Are they statisticians? Are they accountants? Are they scientists? Or all of the above? How do you teach that? It's not simple. I learned trying to do big data many years ago in leukemia that you throw math at a problem and it gives you some very interesting results. It takes a year and a half or 2 years to correlate that to biology. So understanding the basic area of what you're trying to work with is fairly important. Having said that, I convinced both EMC and Intel to come into DELSA as funders. And I think it's extremely important. I brought the issue of Mary Lasker for that one reason, that we have to have multiple people at the table who need to leave their business cards at the door and come and talk in an external setting, forcibly in an external setting, to try and solve problems that are very large. So that's what my thoughts. So.
Anyone else like to comment? Or?
Terrific set of presentations this morning. I really enjoyed this, and I'm thinking in the world of public health that I come from, our world got better when we established these objectives for the nation. For each decade, we establish objectives with respect to where we want to be. 10 years from now, we'll be at some level, and then every 10 years we revisit this. And I'm wondering, how will we know whether we have succeeded in data-enabled life science, and kind of what metrics are we using, and might it be appropriate? Because I'm thinking, we're talking about educating people, getting enough. I can't remember who showed the chart that showed the shortages of people out 10, 20, 30 years. And so I'm asking this in a way, I'm wondering, might a role of DELSA be to help put in place objectives for data-enabled life science, education, training, and again, when you do something like this, it begins to feed itself. You can actually bring a community in, help create these objectives, and then you look at them. They're measurable objectives, and you see, did you meet them, did you not? And you can point to them when you're going to funders, and you can say, we had hoped to cut in half the shortage of projected data scientists within this next decade, but we're falling behind by 30%, and so this is a problem. And so it makes it more data-enabled, if you will, if you have measurable objectives. And so I'm just wondering, is there anything like that in this space? I would assume NSF might be doing something like this, but I don't know.
That is a delicious question, because I think not only is it important to define those outlying success criteria, but I think actually defining what the topic is itself. Because right now, if you can define it, you have a better chance of being able to measure it. So that seems to be a logical role for DELSA. Thoughts?
I would mention that part of NIH's BD2K, the Big Data to Knowledge initiative, is workforce development. And there was a RFI that went out a few months ago. I think that's going to be followed up with RFAs, and it might be worthwhile for DELSA to look into that.
I have an answer.
I'd like to comment on this. This is really great question which we are discussing for some time right now. And hopefully at the end of today, we're going to have some specifics. We're going to bounce by everybody, okay? Specifically, our application to NSF on sustainability, which Jack is PI of, and he's sitting there without commenting, is in part about workforce development as well. Another co-founder of DELSA, Phil Bourne, recently raised that question on a major, PI meeting at NSF. So this is extremely important, and we need to specify. You're absolutely right. Objectives, measurable objectives, and we need to maybe more clarify for ourselves. What's going to be our target for next year? Okay, we cannot cover a lot, right? So we need to be very specific. So we're going to talk about that in our last Q&A discussion, definitely.
I have one idea for one specific thing that could be measured, and that is that a typical science curriculum right now does not include statistics. I think we could replace calculus almost with statistics. And that's something that you could measure. How many universities are including statistics as part of their standard science preparation?
Yeah. Interesting. So I know we're down to a minute here. Should we get a final comment from each one of the panelists? If anybody would like to jump in?
Well, I just want to add to that. Sorry. After you.
So why don't we go with Geoffrey and then kind of go down the road?
So I can make a little comment on the last question. I mean, there are many data science programs, but not very many, and they're pretty incoherent. And so DELSA can presumably help by trying to get some coherence, at least within the life science area, because they're particularly few in life science, although there are many computer science courses which start off with bioinformatics and then go on to become a MapReduce course. That's a typical computer science, data science course. So I think we could, I think this is right at the beginning, and we just need to try to push it along us.
So Sandy, or you kind of, did any final comment you want to make? No pressure. Okay. CJ?
Yeah. So my one final comment, I think at least in Iraq and a lot of places around the world, prizes and challenges work really well, especially if you can incentivize them in the right ways. And so one idea I had, if we could have a life science, data-enabled life science Imagine Cup, like the Microsoft has their Imagine Cup, or the Holt Global Case Challenge, which is on social entrepreneurship. If we could have a global competition and then pick a theme and have a prize every year or twice a year, we could look at what some of the solutions are, what some of the projects are, and then maybe build the curriculums backwards from that, because we'd be able to see what are people coming up with now, given the current educational system and the current tools they have available, and where are the gaps. So I think that might work.
Okay, now I have something. I find one of the biggest challenges for my students isn't necessarily just looking at data and graphing it, it's understanding what the graphs mean and interpreting them. And I think data literacy and being able to read the information that's in front of them would be really important, and we shouldn't forget it.
Absolutely. Great. Michael?
I think the only thing that I would add is, as we look at this, it might be nice to try to retain a international focus so that it's not limited to the U.S.
My final comment and a beware of is and you mentioned it in your presentation, is the tighter and tighter strictures around privacy of health information. I know that is getting in the way in most research areas, but it's something that, at least in the U.S., is not going to go away. As a matter of fact, it's going to get tighter and tighter. So with that happy news.
I can actually add to that, not just the U.S., but the U.K. The National Health Service just levied close to 1.4 billion pounds in in fines for data breaches in the United Kingdom. The US actually had 21 million data breaches in an 18-month period, half of which were lost tapes. But anyway, what I want to say is I'll actually, if Gene wants to do a competition, I'll throw in some storage for free, and I'll convince Intel to throw in some compute for free. So yeah, I'm all for it. I do want to say for statistics education, p-values don't work in big data sets. We need to teach kids scaling and graph theory and spectral analysis. So more engineering stuff than statistics.
Great. Thank you. Please join me in thanking the panelists for great presentations.